So in this video we will study the photon and the neutrino. As always, before we start this, you should have a look at the previous videos, otherwise you will not understand what will follow. So the photon is a very mysterious object. It always moves with the speed of light, and it has no mass. It has some oscillation, some wave. That sounds very strange, mysterious. So if we look on this photon through the eyes of the Daon theory, then we can reach some other conclusion. So first of all, a photon is created inside an atom when an electron moves from one level to another, where the energy is changed, and you have some sort of energies which are collected into a photon. So in the Daon theory, this should be some sort of ordered Daons, which when they are coming out from the atom, they are collected together, and they should create some sort of lump, which should be the photon. Now, of course, nothing happens with immediate. I mean, there is no immediate reaction. That always takes some time to make something. So also the photon has to need some time to be created, to collect all the excessive energy within the atom. That means that the photon has to have zero velocity or very low velocity when it's created inside an atom, and then once it has collected the excessive energy, it will start to accelerate, reaching the light speed asymptotically, which means that the photon has to have some mechanism of strong acceleration. This is what we should examine. So first, what can be the structure of an atom, of a photon? Sorry. So we have already seen the electron and the positron, which has a radial placement of the Daons, and so this photon must have something slightly different. And we can imagine the following image, that is that the Daons are placed perpendicular, parallel to each other. So you have a lump of Daons collected together, all having the same direction, or mean direction, let's say, of their rotational axis. And then you get a lump which again has to be spherical because of the radial equilibrium of a lump of Daons. You have to have a radial equilibrium because of the free Daons surrounding it. So again you have a sphere, but now the Daons are parallelly placed. So that gives you an electric field in a given direction, as you see in this image. When Daon are aligned like that, then of course you will have an interaction between these ordered Daons and the surrounding free Daons, which will lead to a rotation of the photon in the direction opposite to the rotation of the Daons. So you get this equation here, which says that the speed of rotation must be equal to the light speed times the order times the sinus theta, with theta is relative to the rotational symmetry axis of the photon. Okay. So if you have this geometry, then you have to have some equilibrium, a radial equilibrium surrounding it in exactly the same way as the electron. So what happens if you go far away from the photon, then this should be exactly the same thing as for an electron. You have the same radial equilibrium, but when you close in on the center of the photon, you will at a certain radius see that you don't have sufficient number of Daons to have a complete equilibrium until the center of the photon. So you have to have a change at a certain radius of the photon because you have not sufficient number of Daons, and this will lead to a sphere inside the photon which will have the same identical characteristic of each Daon, and they will be put in parallel to each other, and they have exactly the same characteristics and same order, let's say. But on the outside you will have a similar radial equilibrium as for the electron. This means that you can use again the reference radius of the electron also for the photon, because it's exactly the same radial structure some distance from the photon. So now you can calculate the mass of the photon in the same way as you do for the electron. You just take the integral from a given radius, let's call radius rph, which photon, to the infinity, in the same way as the potential for the electron, and you get a mass like similar to for the electron mass. You see here. Okay, this you know already from the electron the definitions. I will not repeat everything. So what is the difference? I mean, you have, in the case of the electron, you have that the interaction on the same shell leads to a reduction of the force when you close in on the electron due to the interaction from between the Daons coupled to the curvature of the shell. But in the case of the photon, it doesn't work like that, because the photons, since they are aligned with each other, they have not the Daon is not parallel to each other on the shell, let's say, because they are parallel to each other in the plane like this, but not on the shell. So you don't have the reduction of force connected to the curvature of the shell, since you don't have a shell structure in the same way as for the electron. And this leads that you have no reduction of the force, it just continue, and it's absolutely constant, the force, radial force, until you reach the level where the radius where you don't have sufficient the Daons anymore to continue, and then you change over and everything becomes the same order of the Daons within a certain radius. So you reach this radius, and then you can calculate the mass also inside such a radius, which you see here, and then you have you obtain then the total mass of the photon, like in this equation here. I will not define everything because you have all the definitions already for the electron, so it's just to make the same thing, in fact. So if you have this, then you can play around with this a bit, and you see that you can, through the definition of energy, we have that the constant of Planck's is equal to c divided by wavelength, and this should be equal to the mass of the photon times c squared, which is a classical, simple, straightforward equation. I mean, the energy and mass is connected in this way. And if you play around with this, you get you can obtain the radius of the photon. You can express this in various matter. I've chosen one here, but you can express it in different ways. So I've chosen one with 2/3 lambda times the fine structure constant. I think this is interesting because you have the size of the photon is connected to its wavelength and to the fine structure constant. So this is a nice combination, I think, of this. Now we will have a look at the acceleration. So how can it be possible that the photon is accelerating so strongly while the electron is not accelerating so strongly? So now we will give its velocity to the photon and see what happens. You have that the photon is rotating at a certain speed, and when you start to move this photon, you find that the photon already has to be placed so that the axis of rotation is perpendicular to the velocity vector of the photon, because if you have some angle towards the velocity vector, the photon will stop. You cannot go against, because you will have the direction of the photon will be such that you have a break if you have some angle to this. This has to be perpendicular, and it has to move in this way relative to the velocity. Now, so if you do that, then you have, if you look to the rotation of the photon relative to the velocity, it's a flux of free Daons going against it. You get that on one side, the rotation will be too fast relative to the free Daons, and on the opposite side you will have that the velocity of rotation is too low compared to the free Daon flux. So in this case, of course, the rotation of the photon will stay constant, and if you look to the force acting between the free Daons and the photon, you get that that since it's misadapted on both sides of the photon, you will have a pressure from the free Daons on the photon on both sides, so that the photon will continue straight away. It will not deviate, but just go on like this, straight forward. But then if you have a look at the shells around the photon, just for the, like same way as for the electron, you have a delay, so you have that the shells are displaced relative to the position of the photon. And in this case of the photon, you will have that you have, since there is a pressure from both sides of the photon pushing on the shells, and then you have that the shells are not centered on the photon, which means that you have an angle in the direction of velocity, which leads to a force pushing the photon ahead. So you can see this is this figure here, and if you make some calculation, you obtain that this force must be proportional to 1 minus speed divided by c. So when the speed close in on the light speed, you have a zero force. So you have asymptotically acceleration until you reach the light speed. So this is exactly what you could expect from this type of calculation. Okay, so why doesn't the electron have the same thing? You might ask yourself, and then you can see that this is a completely different thing, because the electron has a rotation around itself in the direction of speed, which makes that when you have the inclination of the Daons, this is compensated by the rotation of the electron, leading to no acceleration in the case of the electron. So this is specific for the photon. As you see, it will be the same thing for the neutrino, which we will have a look at later on. Okay, so this is for the acceleration. Now we have a look at the associated wave of the photon. So the photon, just like the electron, they get the same electric field. It's of course different, but the result is exactly the same. That is, you have electric field which are creating an image charge. In the case of photon, it can be plus or minus depending on the direction of the spin of the spiral. It's just the same as electron. So you can have plus minus in this case. So you have the electron start a spiraling trajectory in the same way as the electron. And this you can calculate in the similar way as electron, and you obtain the angular momentum in exactly the same way. And this you can further develop, and you obtain the energy law for photons just directly from the angular momentum. You have to put instead of v, you put a c, because since the acceleration goes to the light speed, you get a c in the place of the v, and you have exactly the same thing as for the electron. So you have that the photon energy is also not only equal to the Planck's constant times the frequency. You have also the mass of the photon times c squared. It's straightforward. Transverse velocity, that is velocity of the spiral of the photon around its main trajectory, again you get the square root of delta, the fine structure constant, times c for the velocity, and times the wavelength for the radius of the spiral. So this is quite simple, straightforward, no problem. You should ask for the same thing as for the electron. I mean, this spiraling trajectory doesn't intervene on the velocity of longitudinal velocity of the photon. It's you can have c, it's a velocity, longitudinal velocity, and the transverse movement doesn't influence on that. As you see now, this is you have here separation between photons and electromagnetic radiation. This is two completely different scenarios. The photon, as you see, has a certain direction of its electric field, with magnetic field turning around it. And since the photon is rotating, you will get a variation of the electromagnetic field if you are looking from one point parallel, for instance, to the photon, and you see the variation of the electric field. But in fact, it's just that the photon is rotating, so you see a variation of the electromagnetic field, like if it was a wave. In the case of electromagnetic radiation, you have that the electric and the magnetic field are perpendicular one to the other, and you have a period of electric field, and this transforms to magnetic field, which transforms to the electric field, etc., etc. And the position of the electric and magnetic field doesn't vary, it's always the same. Once it started to irradiate, you have the same direction all the time, so this is completely different from the photon. It's just a lack of understanding of what is a photon, which lead to confusion. Okay, you can also calculate the photon's rotational energy if you like, which we can show here. It's similar as the electron. The rotational energy is quite an important part of the total energy. It's quite strong, so it should be included. Probably it's in the conservation of spin and things like that. It's hidden away a bit. It's no real understanding on what is a spin. It's in fact just the angular momentum, so it's not nothing especially difficult. Okay, so this is enough for the photon. We will now have a look at the neutrino. The neutrino is also a specific geometry, the last one, which is possible directly from the Daons. So I will give you here the schematic view of the neutrino. This is like a torus, a ring, closed on itself. So we have the Daons in some ring shape like this, and of course they will rotate. So you have the same way as a photon, you have interaction between the free Daon and the torus, and you have a rotation of the torus, which creates a magnetic field. So the neutrino is a perfect dipole magnetic field. Since there is no electric field, you have very weak interaction with the other particles around, which is characteristic for the neutrino. When you create a neutrino for some reaction, you will have also wobbling around, but since he has no axis, well-defined axis of electric field, you just see that going perpendicular movement towards the Daons. It's correct the interaction, let's say, so that you have the symmetry axis of the torus parallel to the velocity of the torus. So when you go ahead, this will be stabilizing, and you will have a perfect ring moving in direction of the velocity, perfectly perpendicular. If you look at this, you see that if you have more energy, that is more mass to the neutrino, then the neutrino has to become bigger. And if you imagine that this neutrino has some reaction with another particle, then since its size is varying, its reaction with the particle, specific particle, should happen at a certain geometrical fixed thing. That is that size of the neutrino should have the correct value so that it fits, let's say, on the particles, so they can make some reaction. This means that in a given reaction, the photon reacts only in a certain range of energy mass of the neutrino. And this is important to say that the different types of neutrino proposed today, it's probably just one neutrino which has different size, so that the reaction, specific reaction, happens at a given mass energy of the neutrino. So the neutrino is not a well-defined mass or energy, but it can vary just like the photon over a wide range. So this is probably the explanation for the neutrino interactions. And of course, the mass energy of the neutrino is independent of velocity. You have the same type of acceleration to the neutrino as for the photon, which means that also the neutrino has to move with the speed of light. This will asymptotically accelerates towards the speed of light, just like the photon. It's a bit more complicated mathematics, so I'm not even tried to make some analytic formula. It could probably be made, but so far I'm not even tried to do that. Okay, so I think we will stop there. It concerns the neutrino and the photon. And the next step will be particles in general, which will be quite a big video. Okay.